the key infrastructure requirements to enable edge computing. My name is Dave McCarthy, I'm from IDC. I'm here today with probably one of the best panels I've ever seen. We've got representation from Platform 9, from IBM, from SBA Edge, from Avassa, and also from the Automotive Edge Computing Consortium. And so what I would like to do, because of the conversations we've had already today, is kind of go around the panel a little bit, and I guess I should pass out some microphones because I think this is important. This is an important piece of it. There's one microphone on the table, and then we've got one more here. Instead of me doing introductions, I thought it would be very valuable to allow the panelists themselves to do introductions. So what I'd like to do is start off where, let's just go sort of in this direction. Let's have an introduction, and then because the edge market is so broad, it'd be great to understand like where's your position within it and like what are the types of things that you're trying to solve for your customers. So Peter, I'll start with you.
Hello, okay, can you guys hear me? Yeah, okay, good. So Piotr Mierzejewski, I'm a VP of Development IBM for software-defined networking, and edge applications, and among other Watson applications. So it's a broad, I don't want to focus on those. So my focus is actually on enabling ML at the edge and operationalizing at scale. That's from our point of view, it's being accomplished by having a network actually following applications. And it's a slightly different approach because normally you look at, hey, I got a network, I'm going to deploy the applications. We want to reverse that paradigm. Because the application deployments, especially in the age of the hybrid cloud and edge devices, are constantly expanding. We no longer are standardized in one, let's say, brownfield on-prem. We're looking at distributed applications across hybrid hyperscalers, on-prem, and edge devices. For that, we need the ability to, with velocity, deploy edge gateways to connect those applications, to be able to set up observability on them, and actually handle application placement and management. So I know it's a broad space, but essentially infusing ML into this via having a network actually following the applications.
Excellent. So great for you to be here today.
Yeah, hi. Thank you, Dave. I'm Bhaskar Gorti. I'm from Platform 9. What we do, if you have not attended the earlier session, is we are a platform as a service company. And we run on any infrastructure from public cloud to private cloud to the edge and everything in between. So we are infrastructure and edge or far edge agnostic. Also, on the northbound, applications can be bare metal applications to virtualized OpenStack or truly cloud native. That's where we started and started adding others because many large enterprises, unless you're cloud born, you have a lot of applications that are still not completely microservices and current, and you don't want to run 3, 4, 5 different stacks to manage your workload. So that's where we come in as a unified platform as a service for the company.
Excellent. Carl.
Sure, can you hear me okay? Yeah, you can. I heard myself. That's great. So I'm the CTO of Avassa, and at the heart of what we do is that based on the experiences from working with infrastructure team in large enterprises and learning really the hard way that many of the infrastructures that are built in edge environments today didn't really have the application teams or the developers in mind. We found that in almost all the conversations we had, the application side of the house experienced the edge as something hard to work with, as something that their tools didn't actually fit with, and something that they were expected to manage as a seriously alien kind of entity. So what we're trying to do here is to make the edge as comfortable, as ergonomic, and as easy to reach with their current ways of working, their current tooling, and their current processes. So to make it come alive for them. And that's usually by actually de-emphasizing infrastructure and emphasizing the life cycle of the applications and how to place and schedule and manage them. So that's what we're after here. We're trying to be the connective tissue between the infrastructure and what's usually the CI/CD pipeline.
Excellent. Great for you to be here. So yeah, go ahead.
Hi, my name is Roger Berg. I'm with Denso Corporation. Denso is what we call in the automotive industry a tier 1 supplier. So we build components and systems for customers like Ford, Toyota, Volkswagen, even Caterpillar and Harley Davidson. So we're all across the mobility sector. But I'm here today representing the Automotive Edge Computing Consortium. That is a group of companies, kind of a community, that's we've tasked ourselves with enabling edge computing systems for particular applications in mobility. Primarily, where we see edge as being a great offering for us is in the use cases where time and space need to be put together for example, for safety, for collision avoidance, for automated driving. And that's where we see the edge computing and computation and data storage structure being very valuable for those kinds of applications.
Thank you. Sanjay, you're left.
Thank you. I'm Sanjay Dhawan. I'm with SBA Communications and SBA Edge. We are a wireless infrastructure company. Essentially, we have 17,000 cell tower sites in the US. We've been in the data center business since 2019, and we've been deploying edge facilities at our tower sites. So if you take California, for example, we have just here, we have over 1,000 sites, and essentially each of them is an ideal candidate for off-prem or near-prem edge deployments. And we've been deploying these edge facilities for quite some time, working with partners to bring part of the stack, part of the ecosystem where required, otherwise just providing bare metal and just space, power, cooling, connectivity, security, et cetera, et cetera.
Excellent. So you guys have kept me honest. You're all awesome in the fields that you're in, and you all have different perspectives. And so thinking about what we talked about this morning, there's a few areas that I feel like would be good to dig into. And one is the question around how do you make edge computing real? Because edge computing can feel like a technology. I mean, it is a technology, it is a way of doing things, but it all becomes real through the industries and use case examples. And while we've heard some today, I think it would still be good to say, where are you seeing edge computing happening today? And we'll follow for this particular one, the same flow. We'll reverse it maybe to the next question. But Peter, again, so where are you seeing at IBM? Like, where are the opportunities? Where are the use cases that you're finding the most traction?
Okay, so a little bit of a pitch over here. Today we announced IBM Hybrid Cloud Mesh. It's a new vision of software-defined networking evolution where it actually brings various components of dealing with the edge and software networking into one cohesive solution. And when I mean about components that are necessary to have a scalable, resilient solution that actually allows you to place and manage applications, that allows you to create connectivity between devices themselves and hybrid cloud or close to the cloud on-prem solutions, but at the same time introduces actionable observability that is actually actionable via policies that allows you to do real-time traffic steering based on the application behavior. So it's a paradigm that switches the, hey, I'm going to build out the networks and let's work on applications versus I have a need to deploy application as such, and I'm going to actually move my networks to follow this up while setting up policies as to how this application is to behave based on a matrix that we have from observability tools, while doing the real-time traffic steering based on geographies, price, performance, availability, latencies. So essentially, integrates the solution. And if you look at the data and AI space, this kind of things, everybody hears about data fabric, data mesh. Here, we're looking at, from a networking perspective, application perspective, creating such mesh. Thank you.
Excellent. Yeah, let's keep going around.
Could you repeat the question?
Yeah, so the question is, where is edge computing becoming real? Like, what are the use cases and industries where you're seeing it really get traction?
Okay, definitely. I think the whole question, is it real? It's been real for a very long time. It may have gotten a new name called edge computing in the recent time, but it's been around for quite some time. And when I look at it from Platform 9's perspective, where we see use cases, we particularly focus on use cases where the near edge or the edge sites are not in hundreds but in thousands, because that's where the power of the edge and manageability come in. So definitely we see that in telecommunications. So we have a deployment with one of the largest carriers in the country here that goes up to 10,000 sites. It's not the far edge, but it's a near edge. It's not at the cell site. So we see that quite often. The other one we do see is, automation in stores, all the way from big box retailers to restaurant chains and quick service. That's another area where we see. The third one where we see quite a lot is definitely financial services is a big area in terms of branch ATMs and places like that where the data is getting created, tons of it. And then the fourth area is security, especially cameras and public safety. Those are the four areas where we see at least use cases, and we have production customers in those at this moment.
Yeah, one of the things I found interesting is that video has almost become like the universal sensor. Well, video and audio, as opposed to what people were doing in IoT with hundreds of different sensors.
Yeah.
You can capture the same kind of intelligence if you do it smartly through AI.
Yeah, I mean, give you an example. All the street cameras that have CCTVs, 99.9% of the data is useless, right? Once you have taught the camera the ML model, you're only interested in an anomaly of what's happening. So would you rather send all the data and then figure out what the anomaly is and make a split-second decision at the traffic lights? So I think that's another great example where you can provide public safety using edge computing.
Yeah, excellent. So Carl, where are you seeing edge becoming real with your customer base?
Yeah, so because we're application focused, of course we love it. Well, as a product person, I particularly love it when I have users that can explain to me why they want to use the product. I mean, that's always a good sign. And in all the cases that we have had in the recent times, the driver, of course, is not strategic investment in infrastructure. It is we have this application that we believe in and want to run. So it kind of splits our market into two. There is, let's call them operators or site owners, and we see particular interest or traction in places like retail. We mentioned that, quick serve restaurants or multi-unit restaurants, both environments that are getting heavily digitalized, right? So they are thinking much more about their retail stores and the restaurants as platforms rather than stub-piped applications running on workstation PCs, which used to be true before. But another one that I'd like to point out is that we have a lot of conversations with, let's call them ISVs, right? People that have important, or they believe valuable applications that need to run at the edge. Good example, we have, for example, in our booth, one of our customers called FlashEye. So we have a LiDAR in the booth. Of course, they don't want to take all that data from the LiDAR and create the dot clouds in the cloud, particularly not if you're in a mine. Just like we talked about before here, they have NUC-styled computers running just by the LiDAR. But they don't have a platform approach. They simply want to run their application in hundreds or soon thousands of locations. So it's kind of the opposite from the site owner case. It's driven by their need to provide value, and to provide value, they have to deliver the containerized application close to the LiDAR. So those are the two, right? Either bigger enterprises that have finally found an important application, so they roll forward, or ISVs that must have this to deliver their value.
Excellent. So Roger, in transportation, I have to imagine that you see scale more than maybe other people see scale. And if you think about the complexity of even a passenger car, and let's talk about the complexity of a commercial vehicle, especially like big class 13 trucks and stuff like that. There's a lot going on. So how do you think about like those types of use cases, and what are the types of problems that those companies are trying to solve?
Yeah, well, there are quite a broad array of situations, I'll call them, maybe not use cases, but situations where connectivity and compute is very important for the operational capability of a moving vehicle. Heavy moving vehicles like the Class 13 trucks, or even fast-moving Ferraris, okay? So every situation is different, and so the best way we can assess and conceptualize a given situation on the roadway is to get as much data as we can. And we realized as a consortium 5 or 6 years ago when we first started out that as automobiles started to proliferate some of their automated driving techniques, whether it's level 1 or level 2. They used devices like LiDARs and radars and cameras, not only on the vehicles but on the roadside, to gain a kind of a systematic view of what the situation was around these vehicles and around the infrastructure in which these vehicles operate. So having the more information and being able to fuse all that information together to make it something that a automated driving vehicle could use to choose a pathway or to stop to avoid a collision, that's where we see edge computing being best. In a vehicle, you can't have high-performance computing in 93 million new vehicles every year. So it's kind of a shared distribution of compute, storage, and analysis, if you will, application, if you will. And we haven't really figured that out. What's the optimum distribution of that between the cloud and the edge and the vehicle compute? But that's part of the research we're doing as a consortium.
Excellent. So Sanjay, what's the SBA perspective?
No, thank you. So I think you bring up some really, really good points here. And when we take a step back, what we are seeing is that with the rollout of 5G, with new slicing and new edge breakout techniques, some of these things now you can start to see the early discussions and early signs of technologies coming. Like when you talk about automotive, right? That's an ideal case when you start talking about the smart vehicle and so on, and then you get into some of the other use cases. But from our standpoint, definitely we are now starting to see a number of these breakout scenarios under discussions, edge, cloud at the edge, when it comes to whether it's enterprise offerings or it's coming back to automotive or other verticals like farming and so on. We are even seeing discussions around AI at the edge for some of the smart things like cameras and so on, video cameras for specific use cases and so on. So it is now, you can see that when edge is there, at least I'm talking from a near-prem edge perspective as opposed to on-prem, there are a number of new use cases that are slowly starting to emerge. And I think we'll see more and more of those over the next couple of years as they progress.
Excellent. My goodness. I wish we had 2 more hours. We could actually do the whole day just with this team, I feel like. There's so many awesome things that we could be talking about. And so, Sanjay, I'm going to put you back on the spot, right? We're going to kind of reverse the order a little bit just to try to keep this going. But so great. Lots of opportunity. Lots of interesting things, lots of desires. People want to do this kind of stuff. There's lots of potential. But of course, it's not easy. There are challenges. And among the many challenges, one is the economic challenge. You know, I've talked to a lot of companies that say, we can convince people that this is a great idea, but if the economics doesn't work, they won't buy. Or as a customer, right, the same kind of situation. Like, I want to do these things, but can I afford to do it? So I'm kind of curious, like, so the question here is, what are the key challenges that you're seeing? And if economics is part of it, how are you kind of addressing that for people?
No, I think that's a great question because I think that's really one of the key things. Of course, that's not the only challenge, but economics becomes a key challenge because some of the discussions we have, it's about investing in expensive infrastructure at the edge. And that becomes the first and biggest blocking issue because it's a question who will put up the capital to really build out the edge environment, and versus when the revenues are small. So while the revenues are growing, and it takes time to add revenues because that requires multiple use cases and multiple applications, it's really about building out that infrastructure. That's where we have been focused on building out and investing in that infrastructure as a base layer so that you can get the infrastructure and then applications can start coming and then the money flow, the financial flow can really come into place. But that's only one of the big challenges. The other things that when it comes to edges, when you start getting into hundreds or thousands of edges, to maintain, manage, operate, scale, brings another set of challenges, which I'm sure my my fellow panelists here will talk a lot about, and that's another area we are seeing a lot around, is how do we scale this, how do we manage it, and how do we keep it secure? And those are some of the things that currently we are addressing and ensuring that not only the physical security, but also other aspects of security and so on, and plus managing, monitoring, and maintaining. So we work with partners, we work with when it comes to physical issues, but we also maintain 24/7 monitoring and of facilities and so on, just to secure that we are getting these edges that can be really secure and can be used for multiple applications.
Excellent. Roger, what do you think about challenges and how that fits in?
So our consortium was born in 2018. So for 5 years, we've been talking about mobility use cases. We have architected systems and built systems and demonstrated systems as a consortium, not just as one company, but as a consortium. And we've got to the place where, from an automotive or transportation perspective or mobility perspective, we need to have uniformity in the way we can address or access the network. We need to have some level of ubiquity in where we can attach to the network. It can't be that we only work in New York City and not in Lincoln, Nebraska. So one of the challenges is that widespread uniformity of access to off-board, we call off-board, off-the-car computation and data storage. The second one is really, as I mentioned before, where the optimum spread of that computation and data storage might be in terms from all the way from the cloud to the compute edge in the vehicle itself. And so and that has not been optimized yet, even with all the work that we've done in the last 5 years, has not necessarily been optimized yet. So there's still a little bit of research going on as to how that optimization will manifest itself. So what we've done we've kind of addressed most of the edge computing, I would say, use cases from a mobility perspective, at least that are present today with the capability in the vehicles. And what we found was maybe our marketplace is not big enough to finance this widespread, uniform distribution of edge computation that we need. So now what we've done as a consortium is try to, I guess, spread our wings, so to speak, and look at adjacent marketplaces. It's not just about mobility anymore. It's about adjacent marketplaces that probably need the same type of compute and communications protocols, standards, data access that we need as a mobility sector. And can we form a sort of minimum mass to get enough financing to distribute and to install this infrastructure on a wide-scale basis that we would need for most of our mobility use cases.
All right, Carl, I know you have an idea about what this means.
I'm going to get very tangible with you, Dave. I promised you some specific examples. I have exactly 1.5 examples here for you. The first one is, to me, was very interesting. So this was so if anyone has geeked out as much on retail tech as I've been doing over the last year or two, then they will know that at the heart of the commercial operation inside of any retailer is a point of sale system. They're trying to relabel that now to other things, but it's a point of sale system. There's been this trend over the last couple of years among the point of sales vendors to move the entirety of that system to the cloud. So it's called Cloud POS. What we now see is a very interesting swing back, because many retailers have now found out that if anything goes wrong between the till and whatever local region of the cloud, they simply can't send the customer out of the store with a receipt. So we now see a very interesting, we love, when we talk about it, we call it edge shifting. We see actual POS vendors move components back from the cloud to the edge, because the loss of business that some of these retailers felt when they have everything in the cloud and they couldn't have sub 50 millisecond response times and queues were starting to build up was insane, was crazy. So the sheer profit margin increase of moving the POS back into the store has been spectacular for some of the retailers we talked to, which is kind of counterintuitive, but at the same time, when you think about it, it actually isn't. It's not the entire thing because they love the feature velocity of the cloud delivery model, but some of the critical components needs to be able to survive, upstream outages or anything going shifty like a DNS or whatever it is between the store and the other thing. So that's one thing. That was a very tangible reason for some of our users to move some of the workloads back because of financial reasons. The second thing, and this is a little more ironic, is that we see a lot of the applications, we focus heavily on containerized applications. And hope I'm not getting too detailed here, but we've seen some horrible container sizes because some of the developers have really been brought up to the cloud and they've learned that it doesn't matter. You just pile on. Just don't turn off the debug flags. Never mind if your container is 12 gigs, like 25 operating system size of a single application. And just the overhead costs of running it at that size, and then having the conversation with them, look, you're moving this back to a cluster of NUCs. There's just no way we can fit that kind of application. So just turn off the debug flags and make it reasonably small again. That just took down the amount of resources they need for that application, and combined with actual deep automation, meaning that you shouldn't do USB sticks in each store, that actually reduced their compute needs significantly by just actually trying to live in a more resource-constrained world. So that's the half. The other one was the full. So that's 1.5 for you.
Excellent. Well, it's interesting what you say about the fact that you can create a new paradigm. Doesn't mean that people use it correctly, right? Your example of 12 gig containers, my goodness. Bhaskar, what are you seeing in terms of challenges and maybe how the economic factor fits in?
Sure. One thing I like what you said, imagine you go to your local In-N-Out burger and there's a sign outside and says closed because the cloud is down. Okay, so that's not going to work. So therefore, I think when we look at it, some of our customers, there are two components to quote unquote the cost equation. One is setting up the edge. Okay, and then the second, and which I think is more important, is running the edge. I think those are the two ways they look at it. So, because if you are having thousands of what we like to call cloudlets spread everywhere, your price economics have to be very low to set up the cloudlet or set up that edge in terms of technology, but also in terms of the talent cost that you need to set up that edge. It has to be zero touch. It has to be something that you can, don't have to bring a new talent. The existing talent that runs your store can manage that. Because think about all of us do that in our homes today, right? We set up so many edge devices at our home ourselves. So this edge setup has to become extremely low cost. And of course, the payload is important. And then the second one is the ability to manage once all these edge and cloudlets are up and running. That's another cost equation that companies look at because that eats into the margin of the business. Because they only have so much, depending on the industry you look at, they only have so much margin of running that edge. And you can't eat into that. So McDonald's, as you said, as an example, or restaurants, as you say, as an example, many places, retail is extremely margin sensitive. And so therefore, your ongoing operations has to be extremely low footprint. We have some customers who are managing thousands of stores with 1.5 people sitting somewhere in a cloud center, right? So I think extreme automation, extreme observability, and security built in at the design so that when you operate it, so those are the things that we see. But I think cost is a big thing and talent is a second big thing that can potentially slow down more edge deployments.
Yeah, what I liked about what you said was there's a difference between building for the edge and then like managing and operating the edge. And perhaps we've introduced that term lifecycle into so many other concepts like software development lifecycle. We talk about AI lifecycle. I can't say that I've heard too many people talk about edge lifecycle, but I think it's a thing that we need to delve into further. So what's the IBM perspective on the challenges and how do you solve some of the economic part?
Yeah, so looking from economic prism, because we already built out that, yes, there is a cost inherited with the setup and management of the edge. So let's look at the second part of the equation. And we brought a Jack-in-the-Box, McDonald's, let's say. We look at it from argumentation, looking at the value for the business through argumentation of the workforce. And if I was to use the example of a fast food restaurant, if you had to have 3 crew members to run your shift, and you're able to do with 2 via edge automation, creating the AI-driven drive-through experience that's going to increase your customer sat and get you more customers through, suddenly this becomes viable. But in the same prism that it can't be 2, it's supposed to be placement and ease of operation, so I can recognize that value via work argumentation, versus then this costing me another 2-3 developers to actually keep it up. So 100% there. Additional aspect is argumentation to the whole principles of the business. If I can actually get into the business, slightly different, target different audience, expand my, for example, let's use environmental effects and the impact it has on, the logistics and distribution channels that affect my business. If I cannot get my products into the store because my warehouse is broken or there's flooding here and there, I'm automatically affecting my business. So is there a value? Yes, there's absorbent cost to actually monitor all those real-time devices that give me this environmental effects real-time. However, as I build this into business model, how much does it cost me not to get my products into actual store? So that's where economic viability comes in. Work argumentation, expansion into better, faster reaction to the live events. One of the principles of the edge, I want to have data fast-driven decisions that allows me to argument my business and processes in real time. That's where we see the tremendous value. Yep.
Yeah. So this is where I guess this is where technology hits the physical world. In a lot of cases, is really at the edge. So I would be selfish if I continue to ask questions. So I'm very curious from the audience. Is there anybody that has a question for the panelists? If so, I'm happy to come around and let's get some of this going.
I actually have several, but I don't want to monopolize the thing. So, I come from the microelectronics side of things. So you actually talk about serverless and all those fantastic things. But things had to run somewhere. And the funny thing is you also say that it's very hardware independent, we don't care and all that. But when we go there and we tell you, you want to run on this particular CPU or accelerator, you say, no, we have to run on this other one. We have to spend 7 months validating on this other technology because we have only tested in this particular vendor. So I would like to hear the view from a couple of you at least on how far are we into really going serverless, hardware independent, and making those 7 months into 7 weeks and then 7 days.
Encapsulation, I'm just going to jump in very quickly and pass it along. We've honed on this a few times, right? Encapsulation, technologies like Docker, Kubernetes, create abstraction between the differences in the OS and kernel layers, operating systems, all this stuff. So that's one way what we're trying to address it. However, there's still lack of standardization on APIs and how I register certain devices, how the communication protocols are done. So we need a help from a consortium-like an approach where we can actually standardize on interfaces because my containerization gives me the abstraction and portability. I can repeat it, I can create 1,000 instances on the fly, I can deploy it in a seamless way using operators, I can abstract the OS systems, but if a physical device has not standardized interface that I don't know, I'm going to spend my 7 months. And I have given this answer to some of the clients. So I know the pain, right? But so personally, I think we need to focus on this kind of approach. Go ahead, please.
Yeah, I'll just pile on and say I think people are underestimating the general impact of containerization, independent of what it is. I mean, containers are not just a great universal packaging, even though there's some abstraction leakage, but it also takes care of versioning, upgrades, monitoring, observability. So it doesn't take us all the way there, but if we happen to think about containers as the atom of deployment, and then you can build bigger molecules out of that and deploy them across. So I think it's taken us a great step, and I also happen to agree here, maybe because we work on kind of the same problem space, is that The only thing that we see the need to actually surface to the developers that are in charge of deploying is certain aspects of maybe the hardware. So we see things like it's only meaningful to run this application if there's a camera attached to USB or network-wise, and there's a GPU slice available, and be able to match those two together. A containerized application matching on particular hardware requirements takes us a good step forward.
Now, I think one thing that is also something to consider, to your point, is that there will be applications that will run on a GPU-intensive hardware versus a traditional x86 or something, right? And those different types of applications need to run on those environments. So the key is that for each application at the edge, because now you're at the edge, you're no longer in a large, big data center facility where everything has to be cookie cutter, but rather it has, the whole purpose of edge is that you can tailor to different types of applications and different types of needs. And I think that's where we are seeing that you have to really adapt to those needs, and there will be commonality. Of course, at the higher levels, it might still be the same, but then again, it has to come down to the application providers and what they work with, and then work your way down to the lower layers of the stack.
Any other questions? So I saw your face first.
So with containers and the explosion of the size of them, I'm wondering how long do you think we'll see until like WebAssembly becomes kind of the new normal for the edge?
Sure. I'll start. I think what's really clever and comfortable with containerized applications, at least in the Linux world, is that you can assume POSIX-like development environments. There's nothing like that yet for that kind of environment. So I'm excited to see where all the interface specifications are going. Again, most of the applications that we see takes the shape of a pretty traditional daemon, right? You start, you fork, and you listen and select and KQ and whatever it is. None of that actually exists yet. So I think that's unfortunately a pretty decent barrier for mainstream adoption, and I think it's down to how fast that community can work to fix that. Maybe, a very practical answer.
So as I mentioned, we could go on for hours. And the good news is the show does go on for hours. And if you look around this very area, you see Platform 9, you see SBA Edge, you see Avassa, you see IBM, you see all the speakers that we're talking about today. So I encourage you after this presentation to go out and reach out to the people in their booths, have those conversations, and learn more about the reality of where Edge is today, where things are going, how we solve some of these challenges that are real challenges, and how we continue to move the industry forward. So again, this has been Dave McCarthy from IDC. I appreciate everybody's time. Thank you so much. And let's have a nice round of applause for our speakers today.
Thank you, Dave.
Thank you, Dave.
Thank you to you.
Appreciate it.